Well, it's funny to be at the Technion without Uri, but I understand, as Ronnie said, that this is a festival, that we're celebrating his life and work, and I'm happy to be here with you for that. So I work on matching, and Uri did a lot of work on matching too. Here are a dozen papers that I know of that he wrote on matching, and my talk today is going to touch on two of them. It's going to, in a certain sense, build on two of them. The paper with Yossi Blum on timing is everything, and a paper with his student at Rutgers, Apledo, on paths to stability. But before I get into my talk, I wanted to mention another one of his papers that's joint with me and also with Yossi Blum. There's a paper by Blum, Roth, and Rothblum. And I mention this now just because Guy Rothblum and my son Aaron Roth work in somewhat cognate areas, so a challenge to them is to write a second generation of Blum, Roth, and Rothblum. Of course, they have to identify a Blum and a topic for a paper, but that shouldn't be too much of a challenge. So I'm going to speak about two papers of mine today, one very old and one very new. The thought being that our instructions for this conference were to try to give a talk that Uri would like to hear. And both of these papers will be connected by being about a very particular market, a market for clinical psychologists in the United States. So I'm a little bit of an odd kind of operations researcher. Uri and I got our PhDs in operations research the same year in 1974 at Stanford. I'm a little bit of an odd kind of operations researcher because I'm a market designer. The disciplinary boundaries shifted around me in the course of my career, and so today I'm an economist, not because I'm not doing what I always did, but because today that's what economists do. So I'm going to tell you a bit about how this market works and how the kind of algorithms that Uri spent a great deal of time studying worked. And I'll weave those stories together, first by telling you about the algorithms, and then telling you how they showed up in naturally occurring markets, how they were invented independently in lots of places, but didn't always work as well as we would hope they do when we analyze them theoretically, and how computerizing the market, making a centralized market clearinghouse that used computers, made it work better. So let me first give you a little bit of a model, just to be precise for those of you who enjoy that. I'm going to talk about many-to-one matching. This is sometimes called the college admissions problem, but I'll call the players firms and workers, or sometimes I'll say colleges, and sometimes I'll say hospitals, and sometimes I'll say schools, without apology, because these are the kinds of applications that we've found in the world for these things. And individuals on each side of the market have preferences over who they could be matched to on the other side of the market. And to the extent that these are markets with wages, and the ones I'll talk about today are, you can think about the wages already being incorporated in the preferences. They're part of the job description, and the wage, among many other things, is what determines your preferences over different jobs that you might be offered. And so the information I'll be getting about each individual is firms will have preferences over workers. Worker 3 might be the first choice, worker 2 the second, and then at some point, here's firm I putting itself and its preferences. What that means is anyone they like less than that, they'd prefer to keep the position vacant. And similarly, workers have preferences over firms, and a matching matches firms to workers, respecting the capacity, the demand that firms have for how many workers. And the question is, what kind of matchings might we expect to occur naturally? And one way to get at that is to say, what kind of matchings might we expect not to occur? Well, one kind of matching that might not occur would be one that's individually rational, if it matches some worker and firm such that one of them finds the other unacceptable. So if we're going to build a labor clearinghouse that's going to suggest that that worker work for that firm, but the worker would rather not work for anyone right now than work for that firm, or the firm would rather keep the position vacant, then that won't work. They won't accept that match. More interestingly, a matching can be blocked by a firm and a worker if they're not matched to each other but would prefer to be. So the kind of clearinghouse I'm going to be thinking of, you can think of as just making suggestions. And if the suggestions are such that the people would prefer not to follow them, then the outcome will be unstable. And we'll call it stable if it's not blocked by any individual or by any pair. Now, it's one thing to define a matching to be stable. It's another thing to understand whether there have to be stable matchings. I may have defined something that might not exist. But one of the famous things that David Gale and Lloyd Shapley did, for which David Gale is no longer living, but Lloyd Shapley shared the Nobel Prize in 2012. I shared it with him. One of the things he did is he devised an algorithm called the deferred acceptance algorithm that always produces a stable matching. So let me tell you how that algorithm works in a very abstract sort of way, thinking about it as if, however, firms and workers are doing things, because then I'm going to tell you about this market for clinical psychologists and how it evolved. And you'll see firms and workers doing things that look a little like this. So here's an algorithm, though. You can think of this as working in a computer. That is, we're going to elicit from everyone their preferences. We'll say to the workers, what's your first choice firm? What's your second? What's your third choice? We'll say to the firms of the workers you interviewed, who's your first choice, your second, your third, and how many positions do you have? And then they tell us that we ask them and they tell us their preferences. And then we take these preferences and we have each worker apply to his or her top choice firm. And some firms will get more applications than they need workers, than they have capacity to take workers. And they will look at their preferences for workers and reject those who they don't have capacity for using their own preferences. That is, they won't reject the ones they like best up to capacity, and they'll reject the others. Now, the ones they don't reject, they don't accept yet. That's why this is called a deferred acceptance algorithm. So there are immediate rejections, but acceptances will only happen at the end. So how does the algorithm proceed? The workers who have just been rejected, they apply to their next choice firm. The firms now look at all the applicants they've gotten so far, the ones they held over from last period and the new ones, without prejudice about when they were delivered, these applications. They order them according to their own preferences, the firm's preferences. They keep the ones they can and reject the rest. Everyone who's rejected proposes to their next choice firm. And at each stage, every firm looks at the new applications, keeps the ones it likes best up to its capacity, and rejects the rest. And the algorithm only stops when no more rejections are issued. And that eventually has to happen because no worker applies to the same firm more than once. And at that point, the algorithm stops, and every firm now accepts those applications that it's holding, that it hasn't yet rejected. Now they're accepted at the end. Okay? And Gale and Shapley, there's also a firm proposing version of this algorithm. I won't spend time on it today. Works just the same way, except the firms make offers, the applicants hold on to the best offer they've got so far, reject all the others, keep waiting for new offers to come in, holding only the best one and rejecting the rest. So Gale and Shapley proved two remarkable theorems. The first one is that that algorithm, either version of it, produces a stable matching, a matching that is individually rational because no one ever holds an offer that they find unacceptable, and has no blocking pairs. So how can you see that it has no blocking pairs? This is the only proof I'll offer you today, but the magic of what Gale and Shapley did is it can be offered verbally. Suppose I'm a worker in the worker proposing algorithm, and I end up with my third choice firm. Well, third choice might be pretty good, but it's not as good as my second choice or my first choice. So I would potentially like to work for my second choice or my first choice instead of my third choice. Could I be a blocking pair with them? That is it possible that my second choice or my first choice would also rather hire me than someone who they've been matched with? And the answer is no, because how did it happen that I'm matched to my third choice firm? I only applied to my third choice firm after I'd been rejected by my first and second choice firms, and they only rejected me when they had received applications they liked better. So if I like them better than who I've been assigned to, they don't like me better than who they've been assigned to. So it's a stable matching. And in fact, it's a stable matching when the workers propose. It's a stable matching that's very good for the workers in the sense that all the workers simultaneously do as well as they can at any stable matching. So that's quite an unusual property. One of the things that Uri's work on deferred acceptance algorithms did was it compared deferred acceptance algorithms to various forms of solving linear programs and found that the polytope of solutions had this lattice property, and he understood how the deferred acceptance algorithm climbed around points on that polytope until it found the particular stable matching that it finds. When I started working on this, the kind of theorems that I proved were, I sort of said, when you ask people to tell you their preferences, they're going to want to know why you want to know those preferences and what will you do with them when you have them. And that if you tell the workers that you're going to use a worker proposing deferred acceptance algorithm, then it has the property that the workers can't do any better than to tell you their true preferences. So it's safe for them to tell you their true preferences. I won't talk much about this today, but in a lot of the work that my colleagues and I have done designing school choice mechanisms in different cities in the United States, that's been one of the central issues, whether parents can safely reveal which schools they would like their kids to go to, or whether, as it has happened in some cities before we helped revise the system, it was really important to get whatever choice you said was your first choice, and therefore not safe to say that your first choice is your actual first choice, because that might be too risky. You had to be sure of getting your first choice. This doesn't have that property. Because it's a deferred acceptance algorithm, if you get rejected by your first choice, you have just as much chance of getting your second choice as if it had been your first choice. So that's the property of this deferred acceptance that makes it safe for people to reveal their true preferences if they're on the proposing side. Now, it turns out that stability is important for labor clearinghouses to work. So when we started this work years ago, we looked at a bunch of clearinghouses that we could identify around the world, and we asked the question, do they produce stable matchings, and are they still in use? And we found some correlation. It's a small data set, but we found some association between stable matchings and continued use, and unstable matchings and failure and abandonment. And it's not perfect, but it was very suggestive. But one of the things that we did is we started bringing experimental economics onto the case, where we could control very clearly, keep everything else constant, and see whether stability was important in the success of clearinghouses, and it appears that it is. And I'm going to tell you today about the market for clinical psychologists, which when I start telling you about it, it will be before 1999. It'll be before they started to use a centralized clearinghouse. And I'll let you see what kind of problems they were having that led them to use a centralized clearinghouse, which they do today. Now, since then, we've gotten a lot of experience with these centralized clearinghouses. My colleague Elliot Parenson and I designed an algorithm that addresses the problem of married couples who need two jobs together. And by the time I finish my talk today, I'll have told you a little bit about that, because those theorems I just showed you about how stable matchings always exist, that's not true anymore when there are married couples in the market. But nevertheless, in all these markets, all of these are annual labor markets, except these which are school choice markets, but in all of these ones that are in blue, we are markets where there are couples, and year after year, we find stable matchings in markets with couples, even though we're not entitled to. That is, even though we can show that those beautiful theorems of Gale and Shapley, their conclusions don't hold when there are couples. And so the paper that I'll get to at the end today is about our investigation of why we're doing better than we're entitled to, why the difficulties that you can see theoretically could arise don't in fact arise in the labor markets that we're dealing with. And the answer is it turns out that when the markets are large enough and couples are few enough, the probability that you won't be able to find a stable matching goes down to a low probability. So that's where I'm planning to take you today. So let me tell you about the market for clinical psychology interns. Today they call themselves professional psychology. So these guys are not MDs, but they are a helping profession. They try to make you well when you're distressed. And today this market uses a centralized clearinghouse, but when I started to study it, it didn't. So I'm going to take you back to 1991 and tell you how their labor market worked then. So it turns out they had a telephone market. The way they would get their first jobs is they would go on interviews in a pretty decentralized way. And then there was a particular day. When I studied them, it was the second Monday in February. And from 9 a.m. to 4 p.m. Central Standard Time, they would sit by their telephones, the firms making offers, the clinics making offers, and the psychologists talking on the phone, according to a very strict set of rules, which I'll show you, and which you'll see turns out to be an attempt to do the deferred acceptance algorithm by telephone. Okay, and one of the things about this market. It wasn't working well, and every year they would amend the rules, and I'll show you some of the rules. And what you'll see is it starts with a simple set of rules, and then year after year they add detail, that when we say you can't do this, we mean also A, B, and C. You can't do A, you can't do B, you can't do C. So when you see people making rules like that, it's an insight, it's a first indication that people are doing A, B, and C, right? No one makes rules against behaviors that they're not seeing. So one of the questions will be what's going on if they're doing something like the deferred acceptance algorithm, which is supposed to work so well. Why isn't it working well for them? And one of the things they did as they tried to make it work better is they shortened the length of the market. They used to run it for a week, and then they ran it for, I think, 3 days, and then by the time I looked at it, they were running it for a day. And a little after I studied it, they shortened it to half a day, and then finally they threw up their hands and they asked for help, and we helped them organize a computerized clearinghouse. So one thing we want to get some insight into is what was going on there. Why was making the duration of the market shorter and shorter? Why was that a good idea, or was it a good idea? Were they doing the right thing or the wrong thing? So here's a set of rules at a moment in time. This is in 1991, what the rules look like. They, earlier they had been simpler, fewer clauses. Later they were more complex, but you'll get the idea. So the first rules say that selection day is the second Monday in February, and it ends at 4 p.m. And what that means is that you're not supposed to make offers before selection day. You're supposed to wait till selection day to make offers, and not make veiled offers, things like that. So in particular, by the time we get to item C, it says internship programs may not solicit information regarding an applicant's ranking of programs or his/her intention to accept or decline an offer until after that offer is tendered. We can't say to you, if we made you an offer on selection day, will you accept it? And I've interjected this little ha here. That's a technical term. And what it means is that that rule is almost uniformly violated by the time we're looking at this market. So a giant feature of this market is at every interview you go to, they say to you, so if we were to make you an offer, would you take it? Are we your first choice? And it's a small enough community that where people talk to each other enough that students feel they can't say yes to more than one person. Okay, that if you say to someone is your first choice, you have to say it to only one job. So it puts you on the spot. It's in many markets, when you study the rules from year to year, they survey the market in their own trade journals, and they talk about what's working and what isn't working and things like that. When I've studied legal labor markets, the questions they ask the young lawyers are people following the rules? Are they following the letter of the law? Psychology journals, when they talked about their labor market, they would ask, did you find it very stressful? And this is the thing that people found most stressful, was being put on the spot and having to answer, are we your first choice? So then it says applicants have to reply to offers no later than the closing time, and there's A, B, C, and D that make it clearer and clearer what that means and indicate that there's obviously some problem about that. But here we are in Rules 5 and 6, and they are the deferred acceptance algorithm with firms proposing by telephone. So what do I mean deferred acceptance algorithm? Well, these A, B, and C were in the original rules. They say, you're an applicant, you're going to get phone calls, you have to respond immediately, and an offer can be accepted or rejected or held. And if you accept, it's a binding agreement. If you refuse, they're gone. And if you hold it, it means that the offer remains valid until you notify the program of rejection or acceptance, or until the end of selection day. And you can hold no more than one offer. And then there's some rules indicating that there might be a problem with that maybe some people are holding more than one offer. But there it is. It's the deferred acceptance algorithm. Except it's almost the deferred acceptance algorithm, right? The firms are going to make offers. The applicants are going to hold at most one, rejecting the ones they like less, holding maybe the best one they've got, and waiting, but not accepting it yet, waiting for a better offer to come. The difference is that there's another way that the algorithm can end, except that there are no more rejections. It can also end if time runs out until the end of selection day. So that's going to be an important difference. We're going to see that time always runs out. Okay, but then here's the clue that they're not getting to a stable matching. There are all these subsequent rules that say, you know, an offer of acceptance is valid only if the applicant has not already accepted an offer of admissions to another program. And then, you know, A, B, C, D, and E, they make that clearer and clearer. You know, a verbal acceptance is an acceptance. Before programs extend an offer, they must explicitly inquire whether the applicant has already accepted an offer. A program may in no way suggest that an applicant renege on previously accepted offers. I can't call you up and say, so, Ed, have you firmly accepted any other offers yet? And so the reason I mention these is this is just a clue that they're not getting stable matchings. If the matchings were stable and I call you up and I'd say, I'd like to make you an offer, you'd say, well, actually, I already prefer the offer I've got. That's the characteristic of a stable matching. So there's something going on here after the close of the official market that's leading them to believe that there are blocking pairs, and they're trying to legislate against those. Okay? And in particular, there's this aftermarket at 4 p.m. Central Standard Time. All hell breaks loose because they say applicants who have not accepted a position prior to the end of selection day may receive offers after that deadline, and programs may legitimately place short but reasonable deadlines for responses to such late offers. And I've inserted a smiley face, which is another technical term there, about the short but reasonable deadlines. And let's think why it should make you smile when they talk about short but reasonable deadlines after 4 p.m. on selection day. At 9 a.m. I call you up and I make you an offer. And that offer is open till 4 p.m. And at 10 you get a better offer and you call me up and you say, Al, thank you, but no. And I immediately call up someone else and I make them an offer, and that offer is open till 4 p.m. And at 3 o'clock, they hold it till 3, and at 3 they call me up and they say, Al, no thanks, I just got a better offer. So at 3 o'clock I call someone else up and I say, you know, sorry we didn't get to you earlier, it's been a really busy day, but we're all really eager that you come and work with us next year. And now that offer is open for an hour. It's open till 4 p.m. and it's 3 when I make the offer. At 3:30 you call me up and say no, and I call someone else up. At 3:45 they call me to say no, and I call someone else up. At 3:55 they say no, and I call someone else up. So I've just called someone up and I've made an offer that was open for 5 minutes. That was at 3:55. And now it's time for me, now, you know, they don't accept, it's 4 o'clock, and now is the time for me to call you and leave the offer open for a reasonable period of time. Well, all of those offers have to be accepted or rejected on the telephone. You can't hang up, right? You can ask a brief question or two, but they understand that they have to move down their list fast because everyone has taken jobs at 4 o'clock and the few remaining people are going to be taking jobs very quickly. So after 4 p.m., all the offers are exploding offers. You can't think about them. You can't wait for another offer. You have to say yes or no on the spot. And as a practical matter, everyone says yes. If you haven't gotten a job by 4 p.m., you're in real trouble. Okay? And you take the first offer you get. And this is where all those rules about I can't say to you, so did you accept any, you know, you haven't really accepted any other offer, have you? Come in. You're supposed to tell me right now, sorry, I've taken another offer. But what you might say to me is, you know, I wish you'd called me earlier. I waited all day for you to call, and at 4 o'clock I accepted someone else's offer. So that's why they're not going to be stable. Okay, and then the remaining rules are all about what to do if someone breaks the rules, you know, how to complain, how to report. So you can see this is a market in real trouble. Now, let me tell you a few things about what goes on, what went on in those telephone rooms in those days. So you know, I sort of sat there with a notepad and a stopwatch, and transaction times were fast. These guys have all interviewed already. We've all, before selection day, we've all talked about the job, supposing I'm a firm and you're a worker. We've all talked about the job you might do if you come to me, what the practice would look like, what your responsibilities would be. So when I call you up, it only takes me 5 minutes to make you an offer. It's mostly, and that's mostly not informative. I call you up and I say, we're making you an offer, and then I tell you once again how much we hope you'll come and how everyone loved you, and you tell me how much you liked us. And of course, you could accept right there if we're your first choice. But if we're not your first choice, you say, thanks a lot, you know, I'll talk to you later, and you hang up. And rejections, when they came in, they only took about a minute, right? You call up, you say, Al, I got a better offer, thanks. And we immediately call someone else. So this is a very fast market. Now, there was a lot of willingness of students to indicate if they were the first, if I was their first choice, right? Everyone I interviewed, I said to them, so if I made you an offer on selection day, would you take it? Everyone tried to answer that question. Sometimes they'd say, I can't answer it. I'm part of a couple, and I have to wait and see what kind of job my spouse gets. And sometimes they said, no, you're not, or I haven't decided yet. And sometimes they said, yes, you're my first choice. If you call me on selection day, I will accept your offer. Okay? And it turns out the firms paid a lot of attention to this. We would go sit with firms and with clinics, and they would the two directors would have two telephones, and they'd say, who are we going to call at 9 a.m.? And they'd say, well, let's call candidates numbers 1, 2, 3, 5, and 12 for our 5 positions. And you'd say 1, 2, 3, 5, and 12. When we sat with you and you were assigning those ranks to the candidates, I thought your first 5 choices were 1, 2, 3, 4, and 5. And they'd say, yeah, but we can't leave all 5 positions hanging out there, and 5 and 12 have promised to say yes. So when we call 5 and 12, we know we'll fill 2 positions immediately, and then we'll see what happens with the others. So it was important if someone was your first choice and they asked you, are we your first choice, that you tell them, because that might really matter in whether they made you an offer or not. So here's a complicated expression of the deferred acceptance algorithm by telephone with some randomness in it because of who gets busy signals and doesn't. But the big thing to notice here is just that there's a different way for it to end. If you get to if time runs out, then the algorithm can end, even if there are still offers to be made. And once time expires, then you go into this exploding offer aftermarket where the first time you reach a person who doesn't yet have a job, you hire them if you're the firm. If you're a worker, the first time you get an offer after 4, you take it. So here's a theorem. It's the same theorem I told you before. It said if there was plenty of time, if the stopping time was effectively infinite, then this would yield a stable matching. But from the rules I've showed you, all the ones about how you can't take an offer after 4 p.m., if you've already taken another offer, you should already suspect that time is not effectively infinite. Time does run out, and that's why they have blocking pairs, and that's why they have all these rules about what people who are part of potential blocking pairs can say to each other. So the question is, they've got 7 hours. How do we figure out if 7 hours is enough or not? And I'm going to tell you about one of many simulations we did. This one is of a fifth size of the market. In 1991, there were about 1,000 workers a year in this market, 1,000 new PhDs in clinical psychology. We're going to look at a fifth size where there are 200 workers and 50 firms, each with 4 positions. And it's going to look like the market I told you about. Offers will take 5 minutes and rejections take 1 minute. And other things have to happen in the simulation, but it turns out they're not important, right? The thing is those 5 minutes and 1 minute. And when you run an algorithm like this, what you find is that the mean time to termination at a stable outcome, if you just let it run, right, if you don't put any time limit on it, is 18 hours. Now, let me propose to you that that's surprising. And why is it surprising? Well, 90% of the students have received an offer after 1 hour. 99% of the students have received an offer after 5 hours. Now, 99% of the students, in this simulation, there are 200 students. It means there's only 2 guys who haven't gotten an offer after 5 hours. So what's taking all that time between 5 hours and 18 hours for those last 2 guys to get offers? Well, of course, people have gotten offers here, but they haven't gotten the offers that they will have finally gotten when the deferred acceptance algorithm stops. They've gotten offers, but not as good as they could get if they wait. And indeed, the longest time to termination, was almost 40 hours. So when you look at hour by hour, when you look at what's happening in this market, what you see is a lot of people get an offer in the first hour, and then it slows down a lot after that. And students, and many fewer students, have received an offer from the firm at which they'll ultimately be matched in a stable matching. So what's going on here? Supposing you were flying over the United States in a satellite at 9 a.m. Central Standard Time, and every time a phone connection was made in this market, you saw it light up. So there'd be a line on the map between 2 people talking on the phone. What would you see? At 9 a.m., all the phones would be being used. All the lights would light up. Everyone is calling at 9 a.m., and if I don't get you at 9 a.m., I call back in 5 minutes, if I got a busy signal, and I get you then. So lots and lots of calls are being made, and indeed, in the first hour, 180 people get offers. So if I'm an employer, that first half hour, first hour, I'm making a bunch of calls. I have to call 5 people in the first hour if I've got 5 jobs, and then some of them might reject me immediately. By the time I get to you, you might have already gotten a better offer and just say no on the phone. So I make some other calls, and maybe somebody accepts me right away, someone who said they would accept me if I called them early in the day. But pretty soon, I've got a bunch of offers out there, and my phones are silent. And what I'm doing is I'm waiting for a call. I'm waiting for you to call me and either say, yes, I accept your offer, or no, I got a better offer. Make your offer to someone else. And so I've got my phones in front of me, and they're not ringing, and I'm not making any calls. So you're up there in the satellite, and after that first hour or so, all those bright lines that were lit up have gotten down to very few bright lines. And those lines are each, someone is calling up and rejecting an offer, and then then that firm is calling and making a new offer to someone, to the next person on their list. Well, it takes a minute for a rejection. It takes 5 minutes for an offer. This is incredibly fast, incidentally. When we try to make offers to new assistant professors, we can't make them that fast after we get a turnaround. We have to talk to the dean, and I'm sure that here the deans are very fast. But let me tell you, in the United States, the deans are not always so fast. But this is really fast, right? 1 minute for rejection, 5 minutes for an offer. That takes 6 minutes. You can only do 10 of those an hour. So there are these little chains moving around the country of rejection chains, of someone giving a rejection and a new offer being made. You get a new offer, you might call up the old one that you've been holding and reject it. And they now make a new offer, and someone rejects it, and a new one is made, and they're only going 10 an hour. 10 an hour isn't enough. So after 7 hours, 198, here's the 99%. People have gotten offers, but only 163 of them have gotten the offers that they would get at a stable match. And when you stop the market then, it means lots of people are going to get calls from people they wish they had gotten calls from earlier. And that's where the trouble comes. Okay, so what you see is in the psych model where we stop it at 7 hours and then say after that it's exploding offers, well, the market ends very quickly after the 7th hour. It ends before the 8th hour. It looks pretty much the same about when 99% of the students have received an offer. But now there are blocking firms and blocking pairs. There are on average 16 blocking pairs, students who could be in a blocking pair. That is, students who will get an offer after 4 o'clock that they wish they'd gotten earlier. They've accepted an offer, but now they wish they could reject it and take the new offer. Okay? If they start holding offers, if you dither a little bit, if you don't immediately reject the offer you've got when you get a better offer, then the number of blocking pairs just explodes. Okay? So that's the problem. That's why there are all those rules that say, you really should reject an offer immediately when you get an offer. So the market isn't long enough to, it doesn't go long enough to converge to a stable match. Remember, you had to get 800 something, 900 offers to converge, and they're not even getting 800 offers. So again, what's going on here is the market doesn't have enough time to converge. Now, one question you could ask, remember I started off by saying to you, they used to run the market for a week, and then they moved it to 3 days, and then they moved it to a day. Are they making a terrible mistake? The market doesn't have enough time. Maybe they should have kept running it at a week. But it turns out that's not right. They are right. Why are they right? What determines how long this market is in a way that we care about? It's not how many hours on the clock it goes. It's how close you can get to how many offers you have to make, right? So when I go back here, let's see, when the market could run to conclusion, you needed 881 offers. When it runs for 7 hours with this fast turnaround time, you only get 780. You're missing 100 offers. That's what's causing all the instabilities. Well, supposing you made it a week instead of 1 day. In a week, you can't just sit by your phone all the time for a week. You have classes to go to. You have clinics to take care of. So in a week, when I call you up to make you an offer, I get your answering machine. Even if you get your cell phone, but it goes to voicemail because you're busy doing something. They didn't have cell phones in those days, for those of you who don't remember 1991. Supposing you're pretty conscientious, you're really trying to get back quickly. If it takes you, on average, more than half an hour to get back, then the turnaround time, which used to be 6 minutes, goes up by more than a factor of 5. That means the 5-day market will be shorter, not longer, than the 1-day market. Because what determines how the effective length of the market is how many offers you can get out, how many of those rejection chains you can process. So as soon as people have to step away from their phones, the market becomes shorter in number of offers, in terms of number of offers you can make. So they were actually making the market longer by compressing it so that everyone could sit by their telephone for the whole duration of the market. But they couldn't make it long enough. So since 1999, they've been using a centralized algorithm that uses a variation of the deferred acceptance algorithm that treats couples, which is what I'm going to talk to you about next. But of course, when you computerize it, now it goes really fast. 6 minutes turnaround time for an offer is really fast for a telephone market. But it's not fast at all for a computer that's already got the preferences in it that can run everything almost instantly. So one thing that a computerized clearinghouse does is it eases congestion. It lets you do things fast. Now I'd like to tell you about something more profound that computational assistance does for this market, because it lets you deal with couples. So what's the story with couples? Well, I'm going to tell you a story from the 1970s about the much bigger market for American doctors. This is a market that I've also been involved in. And in the 1970s, well, in the 1950s, when they first started to think about a centralized clearinghouse, there were about 0% women in American medical schools. By the 1970s, there were about 10%. Today, there are 50%. One of the things that men and women doctors, medical students do is marry each other. And as a result, when they go on the market, they want 2 jobs. And one of the things they noticed in the 70s was that they had a centralized match that did something like the deferred acceptance algorithm and produced stable matchings, and it was very successful. These matches are suggestions, but people were going where they were suggested to go because the match was stable, so that if you wanted to go someplace better, you found that they didn't want you. So it was a self-reinforcing system. It was a good market design. Well, when couples started to appear, they stopped showing up where they were supposed to. They were making arrangements outside of the match. So what's the story? What's the story with couples? Well, suppose my wife and I would like 2 particular jobs in California. And if we can't get those, our next choice is 2 particular jobs in New York. And if we can't get those, 2 particular jobs in Boston. And suppose we get a good job in Boston and a bad job in Boston. I forget where I said Boston was. California. Well, we're not very happy. So we would get on the phone and we would look for a blocking pair. We'd look for firms that wanted to hire us that we'd like better, that we could go to instead. So they understood that to get couples to come back into the algorithm, they'd have to think of some way of dealing with couples. And they had a thought on this in the 1970s. So remember, this is the 1970s. Market design isn't developed. Social thought about couples isn't so developed. So what they did in the 1970s is you could register as a couple in the match after being certified by your dean. Your dean had to say that you were a couple. And then you had to specify one member of the couple as the leading member. After you decided which member of the couple was the leading member, you each submitted preference lists as if you were single. And the leading member went through the match as a single person. And then the other member, the one who wasn't the leading member, had his or her preference list edited to take out any jobs that weren't in the same city that the leading member had gotten a job. And then the match was run again, and they got 2 jobs. So this didn't work at all, right? The couples did not come back, and they continued to defect. And as years went on, there were more and more couples, and it became more and more consequential that they were defecting. And the reason is the iron law of marriage, which is that you can't be happier than your spouse. So if my wife and I get 2 jobs in California, and it's one good job and one bad job, we're not happy, right? So we have to find 2 good jobs somewhere. So we get on the phone and we call New York and we say, you know, we just got matched, we're about to sign our contracts, but we're just wondering, because we'd rather be in New York, do you guys have jobs? And they look at their list. We may be talking to 2 different hospitals. We may have different medical specialties, my wife and I. They look at their list and they say, oh, you know, as a matter of fact, they look at their list and they discover that we're part of a more complicated couple blocking pair. They look at their list and they say, look at that. We'd rather have these guys, Al and Emily, than some of the people we've got. So they say to us, you know, by a funny coincidence, we just got an extra position. Why don't you come to us in New York? And then they call up someone else and they say, bad news, you know, the dean has just cut us by 1 position. We're not going to be able to. This is what deans are for, incidentally, right? You can't always blame the government. You know, so this is why when couples were moving around, it rippled through the whole system. If couples weren't going where they were supposed to, then other people couldn't go where they were supposed to, and so forth. So, so one of the things that had to be fixed was that couples had to be able to express their preferences. They had to be able to say, we're not 2 single individuals who have preferences for jobs. We're a couple. We have preferences for pairs of jobs. And our first choice is 2 jobs in California, and our second choice is these 2 jobs in California, and our second choice is these 2 jobs in New York, and our third choice is these 2 jobs in Boston. And it turns out, even when you allow them to express those preferences, the problem is still hard. And the reason it's still hard is that when there are couples in the market, there may not be any stable matchings. So that's something that I wrote about in a complicated way in 1984. But here's a simple example that I'll show you by Klaus and Klein, basically. And so just to give you the idea, here's a simple preference list. There's a couple that consist of students 1 and student 2. They're married to each other. And their preference list in this example is very short. They say the only jobs we'll consider moving from the city where we now live to, you know, to this other city where we're applying for jobs is if student 1, the first member of the couple, gets a job in hospital 1 and student 2 in hospital 2. If anything else is unacceptable, we just won't take any other job. We'll stay where we are. And student 3 says, he's single, he says, my first choice is hospital 1, then hospital 2. There only are 2 hospitals. And the hospitals have preferences over the students, who they see as individuals. These students have different medical specialties. When I interview you, I am not interested in, I may not even know that you're part of a couple. Your spouse is looking for a job at a different hospital in the same city. So just not something I can do anything about. So you can easily check that, I won't go through it because time is running short. There's a simple example. You can easily check that every way of assigning people has it's either assigned someone to an unacceptable job or has a blocking pair. So when you have couples, even when you allow them to state more complicated preferences, the deferred acceptance algorithm might fail. But it doesn't, right? So an empirical puzzle that we have to explain is we now run clearinghouses like this in dozens of annual markets, and we've done it for 20 years now. We never fail to find a stable matching with couples. So the question is, what's going on? We're doing better than we're entitled to do based on the available theory coming into this last paper. And so what I want to suggest to you, we're beginning to get clues of what's going on. What's going on is if the market is large enough and couples are few enough, the probability that you won't be able to find a stable outcome becomes very low. So, so let me tell you a little bit how the algorithm works. What it does, let's think why it's a hard problem to have couples in the deferred acceptance algorithm. Right? Suppose we have a couple proposing deferred acceptance algorithm, and we allow the couples to submit preferences over pairs of jobs. And my wife and I submit as our first choice 2 particular jobs in California. So we apply to them, 2 different jobs in California, and they both like us better than other people who have applied, so they reject some other people, but they hold our offers. They don't accept them yet because they might get better offers. And indeed, in the next round, someone who was rejected somewhere else applies to the hospital that's holding my application, and they like him better. So they hold his application and they reject mine. But my wife and I now want to apply to 2 jobs in New York. That's our second choice. That means the algorithm has to withdraw her from the hospital in California that's holding her position so that she can apply with me in New York. When they withdraw her, they're going to create a potential blocking pair because that hospital had to reject some people they liked in order to hold my wife's offer because they like my wife better. But she's not going to work for them. She's going to be in New York. So the algorithm will no longer be a one-pass algorithm that goes through everyone's preferences just once. We'll have to come back and remember that that hospital in California might have a blocking pair, and we'll have to try to fix it. So we fix it in a way that tries to fix it one blocking pair at a time. And this is how it relates to the second paper of Uri's that I told you about. The first paper was about timing, so I've now talked about that. And in his second paper, he talks about how you can repair unstable matchings by trying to fix one blocking pair at a time in a way that John Vandevate, who wrote papers with both me and Uri afterward, had started to explore. So it's a multi-pass algorithm. And I'm not going to go through it, but the idea is on this side of the flow chart is the deferred acceptance algorithm. But every time a member of a couple gets withdrawn, we put that hospital on a hospital stack. And when you're done, you have to check for instabilities. And you're going to find instabilities where someone was withdrawn from a hospital. And then you're going to have to fix them one at a time in the way that John Vandevate and Uri and I explored. So the empirical puzzle is, why doesn't it fail more often than it does? Remember, I showed you, these dozens of clearinghouses we do, and they work every year. So my students, Fujito Kojima and Parag Patak and I have just finished a paper where we try understanding that. And one of the things that's going on is that when we look at large markets, we find that, we just observe empirically, that people only apply to a small fraction of the firms. Right? Even though there are many firms, in these markets, both for clinical psychologists and for doctors, you have to go on an interview before you'll be listed in the hospital list. And you can only go on so many interviews. Even as the number of hospitals or clinics gets larger and larger, the number of days between November and February when you can go interview stays around the same. So what we tend to find is that it's rare that someone has gone on more than 15 interviews. And when you have hundreds or thousands of hospitals, that means that the lists are relatively short. So we've got some stylized facts that might help us understand why we're doing well. So one of them is there aren't too many couples. The other is the length of the single applicant's rank order list is small. Now, the couples actually have long rank order lists, but they don't have, but that's because of the combinatorial problem of listing pairs. They haven't actually interviewed at more than 15 places themselves. Okay, but they can now have very long lists of how to take their 15 places into pairs. But they haven't interviewed at that many places. So those are the elements that we start off thinking might help us solve this problem. And what we do is we start to look at random markets that have these properties to see whether we can understand why when we simulate these problems, we always find stable matchings for large enough markets. So a random market is going to be this complicated object, but it's going to be a set of hospitals, a set of schools, a set of couples, a set of preferences for hospitals, and some parameters. And what the first of the parameters is going to be the length of how many places you interview. And I'm going to speak of that as if it's a constant. What's important is just as the size of the market grows, it doesn't grow as fast as the size of the market. So it grows, if there are going to be n hospitals and it grows as log n, that'll work fine. But so it goes much slower. There can be lots and lots of hospitals, but you just can't go on lots and lots of interviews. Right? There are thousands of hospitals that offer internships in the United States, thousands of internship programs. And we don't have to make, with those assumptions, we don't have to make many assumptions about hospitals' preferences or about how couples form their preferences. But we do have to make pretty strong assumptions about how many couples there are. So we actually make an assumption that says when we look at the growth of these markets, we're going to want the number of couples to grow slower than the square root of the number of jobs. That's a tougher than necessary bound. People have gotten better bounds than us. But it turns out when it's linear, the results aren't true. The probability of failure won't go to zero when the couples grow proportionally. So those are the kind of things that are going on. You have to put on some technical conditions which say, as you let the market grow, no hospital can become too popular, because if you let that happen, you could have 1 million hospitals, but everyone really wants to be in just one of the first 3, and then it'll look just like a market with just 3 hospitals. So with some strong conditions, the strongest one being the number of couples really can't grow very fast, and some technical conditions, you get a theorem which says that if you have a sequence of well-behaved markets like this, that the markets are getting larger and larger in the sequence, then the probability that a stable matching exists, the probability that little counterexample I showed you crops up, goes to 0 as the number of hospitals approach infinity. And the key element of the proof is when you've got lots and lots of hospitals and lists are pretty short and no hospital is too popular, then even if you have a lot more students than hospitals, but the proportion stays roughly constant as things grow, there are always going to be some hospitals with empty positions. And the way you run into trouble in getting a stable matching not to exist is you have one of these vacancy chains that cycles. But if there are empty positions, then a vacancy chain, whenever someone displaces someone else, becomes, in the limit, more likely to end at an empty position than to end in a cycle. And when that happens, you run out of this difficulty. You run away from this difficulty that the set of stable matchings might be empty. So a corollary of this is that the kind of clearinghouse we've built for all these different labor markets has a good chance of finding a stable matching in a large enough market where the set of couples is small. Now, there's something unsatisfactory about talking about finite markets with limit theorems. So there are lots of open questions. This is just getting our foot in the door in understanding why we're luckier than we're entitled to be. You know, the market design would be a very different field if every time you showed a counterexample to some optimistic theorem, you had to confront that counterexample every time you ran a market. It turns out sometimes counterexamples can be easy to formulate, but they're hard to encounter in the wild, and that's what we're seeing here. But we still have a lot of open questions, you know, if you're interested in this, in how to get theorems about finite markets. You know, instead of talking about limits of probabilities as markets become large, we'd like to be able to talk about what's the probability in a finite market characterized by some parameters that the set of stable matchings will be non-empty. How about if there are large numbers of couples? It turns out, well, in some markets there are more couples. And for computer scientists, we're often getting advice that these problems, like any problem associated with couples and stability, is NP-complete. That is, you can create worst-case examples where even determining if the set of stable matchings is empty would be very hard. But average cases are pretty easy. We always find stable matching. So we need some kind of smoothed analysis. We need to know more about average cases and not just worst cases. So those are all open questions that would be theoretically important and would help explain why we've been as lucky as we have, where we've been lucky, and might point us in practical directions of how we could get luckier where we so far haven't been lucky as we talk about designing marketplaces to make them work better. So let me close by sort of speaking to you as a market designer. What do marketplaces have to do? You know, if you just take Economics 101, you think about all markets as commodity markets. So when you try to buy stocks on the New York Stock Exchange, you don't care who you buy it from. If you're trying to buy 100 shares of AT&T, you don't care whether I've taken good care of those shares while I had them, and I don't care whether you'll take good care of them, whether you have them. We trade anonymously at a price, and the job of the market is to determine the price that clears the market. But markets that aren't commodity markets don't work that way. It's expensive to go to Stanford University, but the price of tuition isn't what determines who goes. Stanford doesn't decide on its freshman class by raising the price until demand equals supply and just enough freshmen want to come. They keep the price low enough so that lots of people would like to come to Stanford, and then they have selection procedures. They try to select among the many people who apply. And of course, they can't just select who they want. They can admit who they admit, but they have to compete with Harvard and other universities to decide who goes where. So matching markets are markets in which you can't just choose what you want. You also have to be chosen. That's why the marriage metaphor comes up over and over when we study matching markets. You can't just choose your spouse. You also have to be chosen. And so when you think about what are the roles of the marketplace, the first role is it has to make the market thick. It has to bring enough people together so that they can transact with each other. But then once you get a thick market, you run into that problem we saw with the telephone market. It becomes congested. If there are so many people on the market, it's hard to evaluate all the transactions that you have to evaluate, because each transaction has to be evaluated separately. You care to whom you are matched, not just the price. So you have to deal with congestion. And one of the things that computers bring to, one of the things that computer-assisted markets can do is deal with this congestion. And then you have to make the market safe to participate in, and that might involve, for couples, solving potentially hard computational problems. So computer-assisted markets can help markets work better in a lot of ways, and over the next century we're going to see lots of markets change because the ability to make computer-assisted markets is going to change as well. So let me just end with some photos. I find I didn't take enough photos of Uri, but I had a picture of him at his desk and at my desk and in Israel and in the US, and we should celebrate all the things that Uri did and would have done if he were here with us today. Thank you.